Hello viewers. In the previous video, I have discussed about traveling salesman algorithm using brute force approach. So let us have a briefing. So the brute force approach consists of following steps. First is modeling the problem where a weighted graph will be given and each vertex will be represented as a city and edges as the distance. And next second is generating tours. You have to start generating all the permutations from a particular city. You have to cover all the intermediary cities and again return to the same city. Now computing the tour length, that is for every tour you have traveled, so you have to calculate the distance. And next the fourth step is finding the shortest tour, that is you have to from all the tours you have traveled, so from all those permutations generated, you have to finally look into the shortest distance or the shortest permutation that is being generated. So that this is what the brute force approach algorithm for TSP. Now let us go through the example. So this is what the graph given. So you can go through the graph with four cities given and the edges P, Q, R, S are the cities and the edges are given with the cost. So you can go through the graph here. So I'll be starting at P. So we'll go from P, and P will be the initial city. I'll start traveling from P and I'll cover all the intermediary cities, that is Q, S and R, and I'll calculate all the number of tours that are generated. Then I'll identify the minimum tour for this. So this is what the graph you have got. Now let us calculate for the first permutation. So my first permutation could be like this. So the first permutation, I can start from P, I can go to Q, I can move to R, I can go to S, and again I can return to P. So this is what my first permutation is. So P, Q, R, S and P. You can see here P to Q to R to S and again returning to the same city. Now calculate the cost for each. So P to Q is 3. So P to Q is 3 plus Q to R is 9. So plus Q to R is 9 plus R to S is 2. R to S is equals to 2 plus S to P is again 8, which is equal to 22 total cost. So this is first possible permutation. P to Q, Q to R, R to S, S to P. See, I am visiting each and every city only once. I am starting at P. So I visited Q once, I visited R once, I visited S once, and again I visited P again. So I'm returning to the same city again. This is how you have to generate all the possible permutations that are present in this graph. So this is the first permutation I got. So now the second permutation could be, so let us see P to Q, Q to S, S to R and R to P. So this could be one permutation. So I'm starting at P, P to Q, Q to S, S to R and R to P. So the permutations are P to Q, Q to S, S to R, R to P. So again calculate the cost. So P to Q is 3. P to Q is 3 plus Q to S is 4 and S to R. S to R is 2 and R to P is 6. So that is equals to 15. So this is second permutation. Now let us go to third permutation, which could be a possibility of P to R, R to Q, Q to S and S to P. So P to R, R to Q, Q to S, S to P. So I have visited only once. I'm starting from P, traveling to R once, R to Q once, Q to S once, and S to P again. I'm returning back. So the third permutation is P2R, R2Q, Q2S, S2P. So this is the third permutation. Let us see. P2R is 6 plus R2Q. R2Q is 9 plus Q2S. Q2S is 4 plus S2P. That is S2P is 8, which is equal to 27. So this is third permutation. Now let us move on to fourth permutation. Okay. Now let us check the fourth permutation. Fourth permutation can be like we can go like this: P2R, next R2S, next S2Q and Q2P. So I'm starting at P. I'm visiting R once, then I'm visiting S once, then I'm visiting Q once, then again I'm visiting P once. So P2R, R2S, S2Q, Q2P. So P2R, R2S, S2Q, Q2P. Let us calculate the cost. Let us calculate the cost. So P2R is 6 plus R2S is 2 plus S2Q is 4 plus Q2P is 3, which is equal to 15 again. Okay. Now let us move on to next permutation. So this could be like let we can start like this: P2S, next S2Q, Q2R, R2P. So let's see, is there any permutation we have already drawn like that? So there is no such permutation. So we are going from P2S, S2R, R2Q, Q2P. So this is one more permutation, that is P2S, P2S, S2R, S2R, P2S, S2R, R2Q, Q2P. P2S, S2R, R2Q, Q2P. So the cost will be P2S is 8 plus S2R is 2 plus R2Q. R2Q is 9 plus Q2P is 3. This is equals to 22. This is equal to 22. Now moving on to sixth permutation. Okay, we can go like this: P2S, S2Q, Q2R, R2P. So this is one more permutation: P2S, S2Q, Q2R, R2P. Let us see, is there any P2S, P2S, S2R we have covered. Now we are covering P2S, S2Q, Q2R, R2P. So P2S, S2Q, Q2R, R2P. So this is what we have taken: P2, P2S, S2Q, Q2R, R2P. Now let us consider the cost. P2S is 8 plus S2Q. S2Q is 4 plus Q2R. Q2R is 9 plus R2P. R2P is 6. R2P is 6, which is equal to 27. So these are the 6 permutations got. So let us check for are there any more permutations. So we have covered almost everything: P2Q, Q2S, S2R, R2P, P2Q, Q2S, S2R, R2P. Next we have covered P2R, R2S, S2Q, Q2P, P2R, R2S, S2Q, Q2P. So we have almost covered everything. So in order to know how many permutations can we generate, there is a formula for this also, which is included as time complexity. So you can also call it as time complexity. So the time complexity, here we got 6 permutations. I'll let you know how the number of permutations can be known initially. How many nodes are there? We have taken as input as 4 nodes. So input is equals to number of nodes n, which is equal to 4. So I have taken number of nodes as 4. I started traveling from one city. So we have a point over here in our algorithm which says that excluding starting city. So generate all permutations of the intermediate cities excluding the starting city. So excluding the starting city, in the sense I am subtracting 1. So 4 minus 1, which is equal to 3 factorial. So I am excluding one city out of 4. So which means that I am traveling across 3 cities. So my starting city is P. I am traveling across all the 3 cities, remaining 3 cities. Therefore it is 4 minus 1. So 3 factorial is equal to nothing but 6, which is nothing but 6 permutations I got. So similarly, if I take 5, so I'll be getting 5 minus 1, which is nothing but is equals to 4 factorial, that is I'll be getting 24 permutations. So for this example, I have taken nodes as 4 number of nodes. Therefore the total number of permutations I got is 6 permutations. So out of this, now the algorithm, so the main motto of the algorithm is to identify the shortest tour amongst all the permutations or tours generated. So first one is 22 I got, next 15 I got, next 27 I got, next again 15, next again 22, next again 27. So out of these, I got two shortest paths, which is 15. So these two are the optimal solutions, which are nothing but P2 Q2 S2 R2P and P2 R2 S2 Q2P, which is equal to cost 15, which is equal to cost 15. So these two are the optimal solutions. So amongst all these 6 generated tours, all these 6 generated tours, I got 2 shortest paths, which are nothing but 2 and fourth one, second and fourth one. So these are the 2 shortest paths. And the time complexity is, so the time complexity for this is order of n minus 1 factorial. Order of n minus 1 factorial. Why? Because why n minus 1 factorial is, I am taking total number of cities as n. N represents total cities, and minus 1 is because I am excluding starting city. Therefore it is n minus 1 factorial. The time complexity is n minus 1 factorial. But the fact of brute force approach is that as the input keeps on increasing, for example, if I take n is equals to 10, so that means 10 minus 1 factorial, which is equals to 9 factorial, that is equals to around 3,62,880, which means that you are getting these many number of permutations. So for the brute force approach, when you are considering brute force approach, if the exponential or the input size keeps on increasing, then you will be getting more number of permutations, which is impractical. That is, it is not generally applicable. So it is not an optimal solution as the input size increases. So as the input size increases, the possible number of tours also increases. So for example, I have taken n is equals to 10, 10 minus 1 factorial, which is 9 factorial. It is giving us 3,62,880 possible tours. So it is not possible to generate those many number of tours as the input size increases. Hence brute force approach is impractical. So therefore we'll be going for other approaches which might generate optical solutions. This is only applicable for the smaller range of inputs, not for the greater range of inputs. So as the input size increases, this is not optimal. So that's why brute force approach is impractical for larger input sizes. As the exponential keeps on increasing, the number of possible tours also keeps on increasing. Hence, brute force approach is impractical for the traveling salesman problem. It is applicable only for the smaller range of inputs. So the time complexity of TSP is n minus 1 factorial, so order of n minus 1 factorial, and this is only practical for the smaller inputs. As the input range keeps on increasing, it becomes impractical. Therefore brute force approach is not applicable for the generation of the optimal solutions. So for the generation of the optimal solutions, we'll be looking into the other approaches as discussed in the previous video. Thank you.